Namaste to all my dear students. How are you? Today I am giving you very interesting video that is about how to balance the chemical equation by oxidation number method and what to see ion electron exchange method. It's very important. So generally that is very important for knowledge as well as examination viewpoint. Yes. So what do you see? Balancing of oxidation and reduction or you can say redox reaction. There are two methods. One is by oxidation number method and B by ion electron exchange method. Yes, so generally in examination ask you to balance by either by oxidation number method or we can say by ion electron exchange method. So you have choice in what you see examination. So today I am talking about the balancing by oxidation number. By oxidation number method, yes. So I have already told you. So always keep in mind. So in oxidation, so always we have to keep in mind for oxidation. Always keep in mind oxidation there is increase in oxidation number. For reduction there is decreasement, we can say decrease in oxidation number. Third one is oxidant, oxidizing agent you can say. So what you see? Decrease in oxidation number. Next one is reductant. What you say? Increase in oxidation number. So always these 4 points we have to keep in mind for balancing of chemical equation or redox equation by oxidation number method. Yes. So in oxidation, increase in oxidation number, reduction, decrease in oxidation number, oxidant means oxidizing agent, decrease in oxidation number, reductant, reducing agent, increase in oxidation number. Yes. So yes, so we are talking about the oxidation number method. So for balancing redox reaction by oxidation number method, we must know these rules. First one is what we see at first oxidant. You know, oxidizing agent, reducing oxidant and reductant are written correctly. Suppose we take very simple example like what's the carbon plus conc nitric acid. When heated, so what we have? Carbon dioxide, nitrogen dioxide plus water. So at first we have to find out which one is oxidizing and which one is reducing agent. So carbon is oxidation number is 0, nitrogen oxidation number is 5, in this case plus 4, in this case plus 4. Yes. So in this case what we see over here? So 0 to 4, it means here what process takes place? Oxidation. Yes. Here what you see? Plus 5 to 4. So what you see? Reduction process. So in oxidation, increase of oxidation number from 0 to 4, oxidation. In this case, oxidation number increase, what you see? Decrease from plus 5 to plus 4. So that is reduction. Yes. So in this case, in this reaction, carbon reduces nitric acid to nitrogen peroxide. So it is reducing So what you see? Peroxide, so it is reducing agent and conc nitric acid oxidizes carbon to carbon dioxide gas. So it is oxidizing agent, or simply we can say oxidant. So we have clear which one is oxidizing, which one is carbon plus conc nitric acid. What we have? CO2 NO2 plus H2. So carbon in this case is reductant. Nitric acid in this case is oxidant, according to first rule. Now according to second rule, find the oxidation number of reducing agent which is increased by let X. Yes. So in this case, when you talk about 0, in this case plus 4, in this case plus 5, in this case plus 4. So what do you see? Oxidation number increases from 0 to 4. So what do you see? 4 minus 0. So how much? 4. What the value of X? 4 over here. Yes. Now third one. Find the oxidation number of oxidizing agent which is decreased by let Y. So, in this case nitric acid oxidizing agents, what we have? Plus 5 to what we see? 4, decreasing over here. So, what we see? Oxidation number of nitric acid is what we see? Oxidation number of in nitric acid oxidation number of nitrogen in nitric acid, how much? Plus 5. Oxidation number of nitrogen in nitrogen peroxide is plus 4. So, what do you see? Decrease in oxidation number. How much? So, what do you see? 5 minus 4. What to get? 1. The value of Y is 1. The value of X is 4. Yes. Is third rule. Now, the fourth rule, generally always keep in mind, generally in redox reaction, in redox reaction, oxidation and reduction takes place in equal amount. So, yeah, if better to say if the ratio of reductant and oxidant, if the ratio of reductant and oxidant is X is to Y, if this ratio X is to Y, if this ratio is reverse, or we can say crisscross, the increase and decrease in oxidation number must be equal. Yes, that is the fourth rule. So, what do you see in this case? According to fourth rule, the value of X is equal to 4 and Y is equal to 1. So, this ratio is reverse, like what you see, if this ratio is reverse, Y is 1, X is 4. So, what do we have? The X value is 1, Y value is 4, according to fourth rule. Now, the fifth rule is having got LHS, means left hand side is balance, the RS right hand side should be balanced by inspection, or it is better to say heat and heat and trial method. You know about the heat and trial method. So, always heat and trial method, at first we have to balance according to heat and trial rule. At first, balance metal in both side, then what is the balance? Then balance non-metal in both sides. At last, oxidation and hydrogen atoms are balanced. So, we have to remember 5 rules. Now, look at the example. So, first one is carbon plus conc nitric acid. When heated, what you get? CO2 plus NO2 plus H2O. So, we have to balance by, in this case 0, in this case plus 5, in this case plus 4, in this case plus 4. Carbon is, here carbon is what you see? Reductant. Nitric acid is oxidant. Yes. So, 4A, for reducing agent. Reducing agent, what we see over here? So, oxidation number of carbon in left hand side is how much? 0. On combined atoms, so its oxidation number is 0. Is 0. Now, oxidation number of carbon in carbon dioxide in product, what do you see? Plus 4. So, what do you see over here? Increasement from 0 to 4. Therefore, increase in oxidation number, what we have? 4 minus 0. What do you get? That X. Yes, like this. So, like this, what to say? B for oxidant or oxidizing agent. So, oxidation number of nitrogen in nitric acid is plus 5. You know, oxidation number of nitrogen in nitrogen dioxide is plus 4. So, what do you see? Decreasement from 5 to 4. Therefore, decrease in oxidation number. What we have? 5 minus 4. What do you see? That is, suppose let Y. Yes. So, we have clear X is equal to 4, Y is equal to what? See 1. According to fourth rule, we have to reverse. You have crisscross. So, this value what you see? Y is equal to what you see? 4. X is equal to what you see? 1. Yes. Now, put the value of over here. So, carbon is how much? 1. So, we never write. Carbon plus how many nitric acid? 4 nitric acid. Yes. So, left hand side, that is the LHS. So, left hand side is balance. In right hand side, what we have? CO2 plus NO2 plus S2. So always we have to balance at first metal, then non-metal, then oxygen, and so how many nitrogen over here? 4. In this case 1. So what we have to do? We have to multiply over there 4. So now the hydrogen number of hydrogen over here 4H. In this case 2H. So what we have to do? We have to multiply by 2. So how much hydrogen? 4. Oxygen is what's 4 3s are 12. In this case oxygen is 4 2s are 8 to 10 to 12. So balance. That is balance chemical equation. Yes. So in this case at first we have to find out the which one is oxidizing agent, which one is reducing agent. Then we have for what is reducing agent, find the oxidation number, increment in the oxidation number. In oxidizing agent, we have to find the decrease in what is oxidation number. According to fourth rule, the ratio of X and Y is something, and the ratio is reverse or crisscross. So increase and decrease in the oxidation number must be what we see. In this case, S equal to 4, Y is equal to 1. So this ratio is reverse. So what you see, S equal to 4, Y is equal to 4, S is equal to, that number comes over here, that number. So this number, what you see, that number comes over here. What you see, this 4 goes over there, 1 comes over here. Yes. So what's Y, the value of 1? That is 4 when what's crisscross, what we have? Y is equal to 4, S is equal to 1. So what you see, left hand side balance carbon plus 4 nitric acid. Now we have to balance the right hand side by inspection. Yes, that's the first example. Likewise, second example, like hydrogen sulfide plus dilute nitric acid. So what do you get? H2O plus NO plus sulfur. Sulfur arrow indicating downwards. What is this? Sulfide has -2. Nitrogen has +5. NO has +2. And sulfur has 0. So what do we see in this case? So -2, 0 increment. So process is oxidation. In this case, from +5 to what you see, +2 decreasement. So what you see, reduction. It means here H2S is reductant because it reduces nitric acid to nitric oxide, that is nitric oxide. Yes, likewise, or see, nitric acid is oxidant. Why? Because it oxidizes hydrogen sulfide into sulfur. Yes. So you have clear which one is oxidizing, which one is reducing agent. Now A for reducing agent. Reducing agent, what do you see? Oxidation number of sulfur in H2S is how much? -2. Yes. Oxidation number of sulfur in RHS is how much? What is it? 0. So what is it? -2 to 0 increase. Therefore, increase in oxidation number is 0 minus 2. What do you get? Plus 2. Suppose that is x. That is suppose x. Yes. Likewise, B. 4 oxidant. So, what do you see? Oxidation number of nitrogen in nitric acid is plus 5. Yes, plus 5. Oxidation number of nitrogen in nitric oxide, that is nitric oxide, is how much? Plus 2. So, what do you see over here? So, what do you see over here? Therefore, decrease in oxidation number is 5 minus 2. What do you get? That y. That is y. 2 is x. So, what's the reaction is like this? H2S plus dilute nitric acid. So, what we have? H2O, NO plus sulfur. So, that is minus 2, you know, plus 5, what to see? Plus 2, 0. Yes. So, H2S is suppose the x is equal to how much? 2. Y is equal to how much? 3. Yes. If ratio is reverse, if this ratio is reverse, so what do you get? S equal to 3, y is equal to what you see? 2. Reverse, or you can say crisscross. So, now what we have? H2S how much? 2 plus nitric acid how much? What is it? 3. So, what do you get? H2O, NO plus sulfur. Yes. So, what do you see? 2 H2S, how many sulfur over here? 2. How many nitrogen over here? 3. So, what do you see? In this case, so nitrogen is how much? H2S. How many nitrogen? 3 nitrogen. In this case, 1 nitrogen. So, what we have to do? We have to multiply over 3 there. Then what is we have to balance the hydrogen? 2H2, 3H, 3, 2 and what is it to 5H. In this case, how much? 2H2O. So, what do you see? So, y when you crisscross, what do you get? The value of x is equal to 3, y is equal to 2. So, what do you see? Y is equal to 2. Sorry. So, what the value of x? H2S how much? What do you see? 3. Y is equal to 2. Yes. So, 2 nitrogen. How many nitrogen? 3 2 is 6. In this case, 2H2, 2H2. So, what we have to do? We have to multiply by 3. So, how many oxygen? 2 3 is 6. And in this case, what you get? 3 hydrogen is what? 3H. 3 2 is 6. 3 2 is 6 to 8 over here. But in this case, what do you see? 2 3 2 is what is 6 2 8. So, how much we have to multiply by 4. So, oxygen is what you see? 6, and oxygen over here is what you see? 4 and 2 6. Sulfur is 1. Sulfur we have to multiply by 3. So, that is balance. Yes. Balance. Yes. Third example. Now, third example. Third example is like this. copper plus dilute nitric acid, what we have? Cupric nitrate plus H2O plus nitric oxide, that is cupric nitrate, that is nitric oxide. Yes. So, what do you see? Copper 0 plus 5 plus 2 plus 2. Yes. So, what do you see? Oxidation, that is 0. What do you see? That is copper is in this case reductant. Why? You say plus 5 to plus 2. So, what is reductant? Nitric acid is oxidant, oxidizing agent. Yes. So, what do you see? So, you have clear which one is oxidizing, which one is see. At first we have to find out. So, X over here, X better, X is equal to in this case, what is it? 2 minus 0, what do you get? Plus 2, 2 minus 0, what do you get? 2. Yes. Y is equal to in this case is how much? 5 minus 2, how much? 3. Yes. So, if ratio is what to say reverse or crisscross, we can say. So, what do we have? The value of S equal to 3, X is equal to 3, Y is equal to 2. Yes. So, put the value of over here. So, what is how many copper over here? 3 copper. How many nitric acid? 2 nitric acid. Yes. So, right hand side is copper nitrate plus H2O plus NO. Yes. So, at first we have to balance, that is left hand side. So, at first we have to balance the metal wise, how many copper? 3. So, we have to multiply by 3. Yes. So, now how many nitrate over here? 3 to the 6 and 1 7. Yes. So, what we have to do? So, in this case we have to add nitric acid over here. So, what you see? 2 nitric acid, 3 copper, so that is what you see? 2H2O. So, what is only what is in right hand side? How many? 6 nitrate, but in this case 2 nitrate only. Yes, and 1 nitrogen is over there. So, what we have? So, we can use excess of nitric acid over here. 3 copper plus nitric acid. Yes, that is the excess nitric acid. Now, according to product, how much nitric acid we need over here? So, what's it? 3 to the 6 and 1 7 over there. In this case, only 2. So, what we have? So, what we have to do? How much nitric acid we need over here? 6. Yes, 6 plus 2. How is it? 6. How many hydrogen over here? 6 and 2. So, what is the 8 H? So, what we have to do? 4H2O. How many nitrogen in left hand side? 2NO. Yes, 2NO. So, what you see? 6, 3 copper plus 2HO, you can eat, that is the excess nitric acid. Why? Because we need in this case. In this case, what you see? 3 copper nitrate plus 4H2 plus 2NO. Yes. So, how many hydrogen nitric acid over here? 3 copper we can write, or we can write 3 copper plus 8 nitric acid. Right hand side how much? 3 copper nitrate plus 4H2O, and I think that is balance. So, sometimes you need extra acid according to what is the product and what is the reactant. Always we have to see. That is the third one. Yes. Now, fourth one is fourth one. So, what do you say? Zinc plus very dilute nitric acid So what we get over here? So in this case, what we get? Zinc nitrate plus ammonium nitrate plus S2. That is the reaction generally given you examination. So we have to balance by what is the oxidation number method or ion electron exchange method. So today I am talking about the oxidation number method only. So what is zinc 0 free atom, nitrogen plus 5, in this case 2 charge, so oxidation number is 2, ammonium how much? -3. Yes. So we have to only what to see focus the compound which have change in what's the oxidation number. So in this case 0, in this case plus 5, so plus 2, in this case minus, in this case no any change over here, plus 5 over here, in this case plus 5, no any change, plus 5 and plus 5. So only we have to consider those compounds which have change in oxidation number. So in this case zinc is what you see reductant, nitric acid is oxidant, oxidizing agent. Yes. So in this case value of X is how much? 2 minus 0, how to get? 2. The value of Y is equal to in this case is plus 5 and minus 3. So what do you get? Plus 5 and minus 3. So what do you see? Minus 3, better to say minus, we can say bracket write down minus 3. So how much? 8. So what the value of X? 2. So you can take what is common over here. So when you take common over here, so what we have? X equal to 1, Y is equal to 4. Yes. If this ratio is what you see reverse, if reverse, yeah, crisscross, yeah, we can say reverse Y is to us. What is the X is equal to what is the 4, Y is equal to 1. Yes, crisscross, or we can say reverse. So what we have in this case? So what you see, zinc is how much? 4. 4 Zn, nitric acid, how to see 1. Right hand side, what to see? Zinc nitrate plus what to say? Ammonium nitrate plus, that is ammonium. That's generally very important, generally asked in examination. So what to see? So 4 Zn. So at first we have to balance metal. So what to see? 4 Zn, so we have to multiply over 4. Yes. So how many what to see? Zinc, 4 zinc, 4 zinc, nitrate is in this case 4 to the 8 and 9, 10. How many nitrogen? 10 nitrogen over here. But in this case only 1 nitric acid. So what we have to do? 4 Zn plus nitric acid, only 1. So what we have to take? 9 nitric acid according to need, according to products we need. 9 HNO3. So what we have? 4 Zn nitrate plus what to say? Ammonium nitrate plus H2O. So what do you see over here? So nitrogen is how much? Nitrogen in this case is what you see 1 and 9, 10. In this case 4 to the 8, 9, 10. Nitrogen is balanced. Now we have to see the what you see nitrogen and hydrogen how much? 9 hydrogen, 10 hydrogen. In this case 4 hydrogen. So what we have to do? We have to multiply by 3. So what we have? We can write 4 Zn plus 10 nitric acid. Yes, 9 plus 1 how much? 10. So what you get? 4 Zn zinc nitrate plus 1 molecule of ammonium nitrate plus 3 molecule of water. Yes, that is also balance. Yes. One last example. These all are very important for knowledge as well as examination viewpoint. So last example 5. So what do you see? Ferrous sulfate plus what do you see? KMnO4 plus sulfuric acid. So what we have? Ferric sulfate, that is ferric sulfate plus potassium sulfate plus magnesium sulfate plus water. That is the reaction. Yes. So what do you see? Ferrous sulfate has plus 2, in this case plus 7, in this case how much? What do you see? Plus 3, in this case what do you say? Plus 2. Yes. So what do you see in this case? That ferrous sulfate is reductant. KMnO5 solution is what you see? Oxidant. I have already talked about in what you see redox reaction. Then so what the value of X is equal to what you see? 2 plus this, from increases from plus 2 to plus 3. So what 3 minus 2 is equal to 1. Yes. Y is equal to in this case is how much? 7 what to say? Minus 2 how much? 5. That is Y already over here Y. Yes. So what do you see? 5. If you keep what you see 5 molecule over here. So what do you see over here? So ferric sulfate is a 2.5 molecule. So 2.5 molecule is what you see? Fraction. In fractions we never consider the fraction. Yes. So what to remove, we have to eliminate fraction. What we have to do? We have to multiply. So when you multiply, what you see? Reverse like this. So what you get? What the value of Y is equal to how? Y the value Y goes over here, X goes over here. Yes. So what do you see in this case? So what you see? 10 ferrous sulfate 2 KMnO4 plus sulfuric acid yes. What do you see? H2SO4 left hand side, right hand side what we have? Ferric sulfate plus K2SO4 plus MnSO4 plus H2O 5 2.5 when multiply doubles what we have? 5 molecule 10 molecule. Yes. So iron is already balanced 10 iron, in this case 5 to the 10 iron. Yes. So now sulfate over here, so 10 sulfate over here, and what do you see in this case? How much? 5 3 ja, what do you see? How much? 5 3 ja 15, 16 17. Yes. So what do you see? 15 16 17 18 sulfate in right hand side. So what we have to do? 10 ferrous sulfate plus 2 KMnO4 in right hand side also how much? 18 sulfate, in this case only 10 sulfates. What do we have to do? Yes. So what you see? 5 F2SO4 ferric sulfate plus potassium sulfate plus Mn multiplied by 2 how much? 2 Mn. So what to get? 2 MnSO4 plus water. When talk about the water, so what do you see over here? Water in this case hydrogen is 8 to the 16. In this case how much? 2s2 only. Yes. So what we have to do? We have to multiply by 8. So what you get? So that is balanced chemical equation. You can say that is the balanced chemical. So in examination, if you ask in examination, so balance by oxidation number method or ion electron exchange method. So today only talking about the what you see? Oxidation number method. If you, for this we have to know 5 rules. If you know 5 rules, we have never problem. So I have already given you 5 examples, and these all examples are very, very important for examination as well as knowledge. So I thank you for watching this video, and I also think you have already subscribed it and convey your friends for learning. Yes, have a nice day. Be happy, be positive. Yes. Next day I will talk about the redox reaction. By ion electron method.